We have seen a very interesting property of sigmoid function. So I hope now it is very clear to you that why I mean the people are interested for using this. But still the solution is not, the problem is not yet complete. We started with logistic regression. To some extent we discussed about sigmoid function. Now we have to go back to the logistic regression again, because yet the cost function we have not decided, right? So let's go back. So you see here, if you just try to make a you know comparison between the cost function that you are using in linear regression and the cost function that you are going to use for logistic regression, you will see that there is basically no changes in this particular equation for error. Obviously error means the predicted output minus the actual output that I have in my hand, where it's nothing but yi cap minus yi, where this yi cap means the predicted one and yi means the actual one for the ith input. But difference is how I am finding this yi cap. In case of linear regression, I am finding just by a linear equation. Just simple linear equation of a straight line. That's why in case of linear regression, this yi cap is simply like w transpose x plus b. It's nothing but y equal to mx plus c, something like that, right? But in case of logistic regression, it's little different. You know that because we apply a logistic function over the linear equation. That's why here it is 1 by 1 plus e to the power wtx plus b. Obviously wtx plus b will be there, but we are you know adding one more layer over there. That layer is the logistic function layer, right? Now there is a problem we will face when we will apply this logistic function layer over the linear equation, that is wtx plus b. What problem we will face? The problem is that this is a non-convex function. So there is a high chance that gradient descent is not going to work over here for this logistic regression situation. But we all know that gradient descent is a very interesting algorithm and very beautiful algorithm for optimizing the error. Already we have seen that. Now exactly what non-convex function, what is convex function, a detailed idea is not possible to give over here right now. But what we can do, we can discuss about this non-convex and convex just side by side. We can have a simple comparison just to make an understand. Just try to understand this. In the left hand side we have a error curve that already you have experienced in gradient descent function. Generally in case of linear regression, this particular type of function is called convex function. Okay, but when we will have a non-convex function, then the error will look something like this. May not be exactly, it's very similar showing from left and right side, but may not be similar, but it looks something like this. And what is a very interesting difference that you can find with these two error curve is that in the left hand side we have a global minima, like we started from anywhere, maybe from this side or maybe from this side, does not matter. Ultimately you will reach to a common point anywhere. But here we have a different situation. Wherever you start, there is a very difficulty you will face to reach in global minima, because there is a pocket present here and there is a high chance that you will start journey from some side, maybe this side, and you will come down, and once you will get stuck in this particular pocket, it's very difficult to come out from here and go down. So naturally the learning will not be completed, and as a result you will never converge your learning algorithm. What will happen? The algorithm will try to learn, but algorithm will always find itself that I have not learned properly, I have to learn more, I have to learn more, and never learning will get completed, because the you are in some pocket, you stuck in some pocket, which is basically we call local minima, which is not a global minima. So that is the problem for a sigmoid function. So that's why I've written that as sigmoid function is a non-convex function, therefore to ensure global minima, we must convert the non-convex function to convex. We have to do that. Question is that how we will do this, right? So let's try to see how we can convert a non-convex function to a convex function, which will be further useful for applying the cost function in logistic regression.